Hello everyone. So today in this video, I will be solving MCQs paper 1 to October, November 2021. So I will solve first 5 MCQs of this paper, and I will complete this whole paper in each video. I will be solving 5 MCQs of this paper. Okay. So in this video, I will try to solve first 5 MCQs. Okay, so let's start. Question 1 is, which row shows what all physical quantities must have? So all physical quantities, we have to find what are the characteristics that all physical quantities must have. So in option A, that the magnitude, direction, and unit. You know that all physical quantities do not have direction, because scalar quantities do not have direction, only vector quantities have direction. So option A is incorrect. Okay, because the direction is not required for all physical quantities. In option B, magnitude, direction, and unit. Unit is not required in this case. You know that all physical quantities must have unit and magnitude. All physical quantities must have magnitude and unit. And vector quantities must have magnitude, unit, plus direction. This direction is required for vector quantities, not for all physical quantities. So that's why option C is correct. Magnitude is required and unit is required for all physical quantities. So this was very straightforward question. So option C is correct. Okay, so let's do question 2. What is an alternative way of expressing an energy of 43 decijoule? Okay, so this question belongs to prefixes, and let me tell you that you know that deci stands for 10 to the power minus 1. So 43 decijoule mean 43 into 10 power minus 1 joule. And this is, you know that this is equal to 4.3 joule. Okay. So let us check this option A, 4.3 into 10 power 3. This M stands for milli. Okay. So this M stands in this option, M stands for milli. So we have to convert this into joule, that is 10 power 3, and you know that milli is 10 to the power minus 3. Okay, so if I simplify this, I will get 4.3, and this is 10 power positive 3 negative 3, that is 10 power 0. So that is 4.3 joule. Okay, so this is 4.3 joule. So 43 decijoule is equal to 4.3 joule, and 4.3 times 10 to the power 3 millijoule is also 4.3 joule. So this option A is correct. We do not have to check the other options, because the first option is correct. That is 4.3 into 10 power 3 millijoule is equal to 4.3 joule. And if you want to check option B, and just for practice, that is 4.3, 10 power 3, and this capital M stands for mega, and you know that mega is 10 power 6 and this is 4.3 into 10 power 9 joule. Okay, and if you want to check this C, that is 4.3 into 10 power minus 3, and this M stands for milli, and that is 4.3 times 10 power minus 3, and this milli stands for 10 power minus 3, and this is, if we simplify this, we get 4.3 into 10 power minus 6 joule. Okay, so in option D, this M stands for mega. So if you will simplify, this will be equal to 4.3 into 10 power minus 3 times 10 power 6 joule. Okay, so option A is correct. This is very simple question. So question 3 is, a tennis ball is hit so that it leaves the rocket with velocity v at an angle of theta to the horizontal. Okay, this v is velocity of the rocket, and that is the direction of velocity is at theta with horizontal. The vertical component of velocity is vy. What is the magnitude of horizontal component of v? So what we have to find, first of all, I should tell you that this question belongs to the resolution of vectors. Okay, so this vector v is resolved into two components. One is horizontal component and other is vertical component. So we have to find the horizontal component, and you know that the horizontal component of this v is, this is theta, and this component is v cos theta. Okay, so if you want to find vertical component, then this is v sin theta, just for practice. So this horizontal component is v cos theta, so option A is incorrect, that is v sin theta. And in option B, this is vy cos theta. This horizontal component is the part of the component of v, not the component of vy. Okay, vy is the vertical component, so horizontal component is not the part of this vertical component. This horizontal component is the part of this v, the vector. Okay, so that's why B and C are also incorrect. Okay, so how this D is correct? Because in our case, this horizontal component is v cos theta, but we don't have any option that is equal to v cos theta. Okay, so in option D, this vector horizontal component is written as v square minus vy square whole power 1 by 2. And how we obtain this answer? You know that this horizontal component, if I write this, if I draw this right angle triangle and this is theta, this is horizontal component, that is vx, and this is vy, and this is v. And what is the relationship between this vector v, vy, and vx? You know that this relationship can be written as using Pythagoras theorem, that is vx square plus vy square. So we have to find vx. So let's make vx as subject of formula, that is v square minus vy square. So that is, if I take square root on both sides, so I will get this option. So horizontal component, the magnitude of horizontal component is given by v square minus vy square. So option D is right choice for this question. So let us solve question 4. For excuse me, for cathode ray oscilloscope, CRO screens each delay a waveform. The screen and the time-based setting of each CRO is shown. So this question belongs to the measurement from cathode ray oscilloscope. Okay, so you know that what we have to find which screen shows waveforms of the same frequency. We are given 4 options, 1, 2, 3, 4, and the CRO displays 4 different signals. So what we have to find, which 2 of these signals waveforms have same frequency. And you know that frequency is 1 over time period. And from CRO, we can find time period. Okay. How can we find time period? You know that time period, let us find the time period of this first signal. You can see that this signal repeats, this signal completes in 4 divisions. Okay. This is complete waveform. So there are 4 divisions and time-based setting is 0.02 seconds per division. Okay. So what is time period of this signal? You know that how to find time period. We multiply number of divisions that are 4 into with time-based setting, that is 0.02. Okay. So we have 4 divisions and each division is equal to 0.02 second. Okay. So the time period is 0.08 second. The time period of this signal is 0.08 second. So we should work for time period of each option, and if we have 2 signals of the same time period, then we will have same frequency. So do not need we don't have to calculate frequency. So let's find the time period of second signal. You can start from here. You know that this signal completes in 2 division and the time-based setting is 0.04 second per division. So time period will be 2 divisions times time-based setting, that is 0.04. So this is 0.08 second. So you can see that the time period of these 2 waveforms, 1 and 2, is same. So the frequency of these 2 waveforms is same. Okay, so we do not need to calculate, check the frequency or time period of second 2 signals. But if you want to check, if you want to verify or check, you can see that this in option 3, this waveform completes in 2 divisions. So time-based setting is 0.02 seconds. So time period of this signal is 2 times 0.01, that is 0.02 seconds. You can observe that time period of this signal, this waveform, is not equal to 0.08 seconds. Okay. So if you want to find the time period in options in signal given in option 4, this signal completes in 4 divisions, and time period is number of divisions time-based setting, that is 0.08. So you can verify that, you can see that what is the time period of this signal. So 4 times 0.08 gives you, that is 0.32 seconds. So just for your practice, I have calculated the time period for all options, but you can see that in waveform given in option A and in option B, you know that they have the same time period, so they have the same frequency. So what is our right choice? Option A, waveform A and waveform 1 and 2. So option A is correct for this question. Very straightforward question. Question 5, a student measures the time t of one complete oscillation of pendulum of length L. Her results are shown in the table. Length is 0.42 plus minus 0.01 meter, and time period is 1.3 plus minus 0.1. She uses the formula 2 pi L over G under root to calculate the acceleration of free fall. What is the best estimate of percentage uncertainty in value of G? So this question relates with the uncertainties calculations and their rules. And we are given the absolute uncertainties in T and L. So what we have to find? We have to find the percentage uncertainty in G. So what we will do, first we have to make G as subject of formula. And you know that if I take square on both sides, I will get 4 pi square L over G. So if I make G as subject of formula, that is 4 pi square L over T square, you can do that. So you know that this is the division case, and two quantities L and T square are divided, and this is constant. And when in case of, you know that when two quantities are divided, that Z is X over Y, then fractional errors are added to give you the fractional error in Z. Delta X over X plus delta Y over Y. This is fractional error in Y, fractional error in X will give you fractional error in Z. Or if you multiply this equation by 100, what will you get? You know that delta Z over Z times 100 and delta X over X times 100 plus delta Y over Y times 100. So what are they? This is percentage error in X, percentage error in Y will give you percentage error in Z. So percentage delta Z is equal to percentage delta X plus percentage delta Y. In case of division, percentage errors are added. And if you have any constant multiple with X over Y, then this constant will have no contribution in percentage or fractional error. So let us write equation for this. You know that delta G over G, first find fractional error and then for percentage error multiply with 100 at the end. So this 4 pi square will have no contribution in fractional error. So that is delta L over L plus this T square, the power is 2. So this power is multiplied with this fractional error. Okay, so this is another rule. If you have this is also derived from this rule, that if you have Z is X square over Y, then this 2 will be multiplied with fractional error of X. So delta L over L, that is delta G over G. What is delta L? You know that delta L is 0.001 and the value of L is 0.42 plus 2 times what is absolute error in T, that is 0.1 divided by 1.3. Okay, so from this relationship you will get delta G over G. If you use your calculator and you multiply, you evaluate this thing, then you will get, that is 0.156. So for percentage error, you will multiply this fractional error with 100. So if you multiply with 100, then what will you get? Will get as 15.6%. Okay, so that is equal to approximately equal to 16%. Okay, so that's why D is correct and these all other three options are incorrect. So for such type of questions, you have to use the rule and you have to evaluate the simplify and get the final answer. And without getting the final value, you cannot estimate these percentage errors. Okay, so what you have to do, you have to use the rule and you have to put the values and then you have to get the answer. Okay, so that's it. Thank you so much.